apologize, I really chose to be in at the wrong time. Chris is currently a student in my 499 class where we are looking at certain types of statistical modeling, either Bayesian or classical frequentist approaches. Christopher has chosen to look at a very classical approach, which is just regression, on a very particular subset of data, but without further ado, Christopher speak on that behalf.
So, I worked closely with ACE for approximately a year now, and a question that came up with ACE was, well, how productive are we in our tutoring? How well are we executing our methods to improve students' grades? Now, this is a question that we can have thousands upon thousands of lines of data, but unfortunately I wasn't able to get it cleaned up in time, so I have a smaller set of data that is specifically supplemental instruction within tutoring. So we still have data, it's just, it's going to be a whole lot smaller, it's going to be a little bit different. So what is regression is the first question for those of you that don't know what it is. From Google, it's just a measure of relation between average value of one variable that corresponds to certain values of other variables. In terms of like a physics lab, they'll do best fit lines. That's the same exact thing, just a little bit less accurate. So why do we do regression? Regression is something that we have a relationship between predictor variables and response variables. In a classic science sense, such as a biology class or a chemistry class, we would have one independent variable and one dependent variable. But with something larger like 3 or 4 independent variables, they could be dependent upon each other, so we can't really call them that, and that's why we're calling them predictor and response variables. So regression is useful for predicting where our next data point might be. So next is, how are we going to use it? For smaller amounts of data, as in like 3 to 10 points, we can probably do it by hand. It won't be that bad. But in this day and age of data, oh boy, there's a lot of data. And when we have, 5,000, 10,000 lines of Excel spreadsheet data, I don't want to do that by hand, and I don't think anybody else does either. That would take years compared to what we can just use R and Python for, which are coding languages that the world of data science has jumped on as the 2 best coding languages to execute this type of coding and sifting through data. So in this project, I'm going to be using R because I already do Python, so might as well learn a different language, right? Just challenge ourselves. Here's an example of our code for linear regression. Now there's a lot of math behind these functions that took us approximately 2-3 weeks to learn. So there's a lot more behind this than just these 12 lines of code, and that's with spacing. So there's a lot of math, but somebody figured out how to just make it 12 lines of code, and we're just going to keep it that way for this presentation. So here's a plot for ideal data. Ideally, if we're doing linear regression, we want it to be a line, right? That's the whole point. But ultimately, this is more realistic. We've got a lot of error, a lot of variance in here that is not going to present us with just this easy, oh, there's a line. Honestly, I can't even see the line that they made and how they got it there, but the computer did it. That's the minimum amount of error, so we trust what the computer does, and it gives us a nice way to predict what's going to happen in the future or for to add something else into the data. So, but what if these variables are not related? Like, what if we had something like run speed and the color of the sky? Those are completely unrelated, so there's no relation between the two. You end up with a horizontal line, and it basically says there's no relation. Why are we doing this? And it should ultimately be cut from your program so that we can use our data space for something more productive, like what is the level of exercise compared to BMI or something to that effect, where we've got something more relevant than the color of the sky and how fast you can run. So how does it apply to tutoring? Well, I have 3 questions here. what becomes the point of diminishing returns? How long can I stay studying before I just start to lose productivity? How long can I be there before this tutoring is less effective than me just going home and taking a nap? So that's a good question, and this is something to answer with regression. Another one is, what's the optimal time to spend to improve my grade from, let's say, a D to a C? That's a realistic expectation about halfway through the semester, and I don't know that number, but linear regression can help us say, you know, you can spend anywhere from 5 to 7 hours in tutoring, and then your grade will improve, which is useful. It allows us to say to a student, if you want a D in that course and you currently have an F, spend this many hours in tutoring, you'll pass, which is very useful. So another thing about tutoring is we can't forget that there are other applicable factors. Tutoring is not the only thing that influences somebody's grade. There's a level of intelligence. Well, how do we measure that? That'd be something like an ACT score or some other standardized test score that'll give us just a ballpark answer of, you know, they're approximately in this area for this subject. Another thing is placement tests. Like for this example, we're going to be using MS-112 data, and in MS-112 we have a math placement test. So that'll give us a little bit more accurate picture of what's going on within math itself. So that tells us their math strength and where they're deficient inside of math. So it's a little bit more accurate than ACT score, but it's still pretty useful. So prior coursework is another question. We have an MS-100 course, which is more remedial math and getting the basics solidified before they can move on to something like pre-calculus algebra. If they have this prior coursework, then would they have a better foundation than somebody who placed high enough to get into the course? That's another question. All of this can be answered with linear regression. So here's data from supplemental instruction, MS-112. We have 0 as an F, 4 as an A, and grade point averages in between. So it looks kind of like a triangle. Now, when I applied regression to it, I got a line that says that SI is bad. I'm like, wait, we're helping students. This doesn't make sense. So I went back and I looked at the data of a different class, and it was varied bivariate, or it had 2 humps instead of 1. One that was floating around B and one that was floating around D. That's not great. That means we've got some people that are successful and some people that aren't. There's just a huge disconnect. But apparently SI takes that data and it forms it into something that looks a little bit more like a normal curve. Now, I rotated this graph so that I can make the normal curve look nice and pretty on top of it. And I also have this blue line as the mean. The mean, I don't remember the number, but it's on the next slide, so we're going to get there. But it looks like a normal graph. It looks like a bell curve, which is about what we expect in a course. So if we're going from 2 humps to 1 hump, that's good. That means we're starting to have normal data. That means it's easier to predict. And then also, this mean is not exactly on 2. So if it's not on 2, that means we're either going up in a direction or down in a direction. In this case, we're going up. So that means something productive is happening here. Now, what's happening? I've only had this data since 11 o'clock this morning. I need more time to discern. But it's very useful to be able to say, well, we're above the average on a bell curve. That's good. So the mean for MS-112 GPA is 2.07. Obviously that is higher than 2. Not by much, but anything will help a student. And this is also approximately 120 students that we're looking at. So the more students that we add in, the more data points we have, the more accurate this will become. And apparently the more it'll look like a normal curve. So we're getting something out of here. We're learning something. And the future of this project, as in anything past today, because I've only had it for today, is that we can apply this to all courses that we offer tutoring for. So say that somebody's struggling in English 101. we can say, all right, we need to spend X amount of time in the writing lab, and that will adjust your grade to where it needs to be. We can say, well, if they're struggling in biology 204 or something, we can say, this is how we're going to adjust the grade, or tutor you long enough to adjust the grade back to where you need to be back on track. So this is ultimately a way to say, this is how we get back on track. So a task for better data, because as we looked here, I get F, D, C, B, and A. That's all I've got. So higher detail in grade reports. If I was given, everything on a 100-point scale, we could be more accurate because we could tell you, this person made a 78. That's still a C, but that's better than a 70. So we could further say, well, we looked at this data, and if you need a C, we can accurately get you there quicker because of this more accurate data. And it gives us easier accessibility to these higher details if we have those higher details so that we can just say, we're currently at a 68. That's going to be a, 1.8 on a grade point scale. So we can accurately say, from a 1.8, we need to get you to a 2.0 to pass this class. You need this many hours of data. So outcomes with more accurate data is that better prediction capability and better record keeping. Because better records means that we have better data that we're good, right? So that is end of slideshow. Do we have any questions? Yes, sir.
Okay, you may not be able to answer this because of the information is going to be private. I'm just wondering, the students who go over to ACE, for example, do they go over primarily the objective of I need to get to a certain grade in this class, or do I want to do as good as I can, get the best possible grade I could get?
From my experience as a tutor, we have both. There are a lot of students who are within what they consider failing range, and failing can mean anything from a D, F, or sometimes a student's interpretation of failing is a B, and they want to make that passing grade. So that's a lot of our student population is they don't want to fail in their terms, not in our terms as a university. So that's more of the people who will come in.
I guess mine's more of a comment. You talk about the two-hump curve
Yes.
there. We've been doing a lot of data analysis in the anatomy and physiology labs, and me and Dr. Burns have been working with Pearson, which is kind of an online tutoring, if you will.
Yeah.
And what we noticed in a very brief amount of time was that the Pearson seemed to push, you would think we would get away from a two-hump and more to a normal distribution, but it seemed to push it to more of a bimodal distribution. And so you ended up with a lot, the F's being a lot different than the A's. It was just kind of a weird, thing. It went counterintuitive to what we taught.
That is most likely because who has initiative? Who would have initiative in your course? Who would want to get that better grade? And then there are other students that don't. And then it just further makes a divide.
Yeah.
But with the way that SI is set up, I'm sitting there in the class, and I'll answer your questions before class, I'll answer it during my session. And a lot of students, for me, I had, last semester was 15 distinct students, 97 visits. So that is definitely out of the normal. But with that knowledge, I had a lot of students coming in consistently asking for help on these small topics, and then they knew that I was the person to come to ask questions. So with it being a little bit more personal than just walking into this room that's real intimidating, honestly, it makes a difference.
It is. I was just wondering if maybe if you looked at your data and you took your A's and B's and looked at regression on that one, and then looked at the lower end and looked at that rather than try to lump it all into one. What I was thinking. That might help your regression.
Yeah, because I did have a very weird distribution because I had so many C's, but also MS 112 is a course that typically has a lot of drop, fail, withdrawal rates. So with that, having those Cs is actually not bad because they're not failing.
Oh, yeah, that's good.
Okay, so let's thank our speaker.